Okay, so we have these two equations, and you were asked to solve them. Okay, now two ways to solve. You could multiply, say, this equation by 5 and this equation by -4, and that would give you coefficients of 20 and -20 on x, so that when you add the two resulting equations, the x gets eliminated, you get a y, and you can solve that. People did quite well with this. And some people chose, well, there's a natural way to do it. You have a negative and a positive here, so just multiply this one by 7, you're going to get -21y, among other things. Multiply this one by 3, and you're going to get +21y. Of course, everything else in this equation will have to be multiplied by 7. Everything else in this equation multiplied by 3, but I think we understand that. And you add the resulting equations, you can see that the y's are going to go away. Okay, so either way you want to do it. And you can verify that x equals 1, y equals 2 is a solution. And you should run through that if you didn't in class. Or if you didn't get it in class, run through it and make sure you understand. Okay, but what we really want to do now is graph these two functions, okay? So we didn't originally have this graph here. We did this stuff and we started to create a graph, and then we realized that we needed a more extensive graph to get all our points on. Okay, well, how do we do this? Okay, well, over here we solved each equation for y and used the slope and the y-intercept. Here we're going to just go ahead and get the two intercepts, the x-intercept and the y-intercept. Okay, so we want to graph 4x minus 3y equals -2. What do? Well, we say, okay, the x-intercept, I hope we're used to this, the x-intercept is a point on the x-axis, and the x-axis is the place where y equals 0. So the x-intercept is characterized by y equals 0. So we plug in 0 for y. We get 4x minus 3 times 0 equals -2, and we solve for x. Well, that's very easy to solve for x. You get x equals -1/2. You should verify that. And most people did in class. But if you missed class, you should verify that. Okay, anyhow, x is -1/2, meaning the x-intercept is -1/2, 0. So we went ahead and plotted that point here. It's been smudged a little bit. It's -1/2, 0. And you can see if this is 1, this is -1, this is 1, this is -1. Well, right there is -1/2. The y-intercept occurs when x equals 0, because the y-intercept is on the y-axis, and everywhere on the y-axis the x-coordinate is 0. I'm kind of looking at the, okay, yeah, but I just noticed on the little screen I'm looking at that my hand was tilted a little bit. I felt like it was straight. And it was tilted quite a bit, so I'm going to have to check my own proprioception. Okay, so anyhow, okay, the y-intercept occurs when x is 0. So you have 4x minus 3y equals -2. In this case, you're going to plug in 0 for x and solve for y. Well, we do that, and we get y equals 2/3. Again, I don't think people have much trouble with this, but make sure we understand why we're doing this. Giving us a y-intercept at 0, at 0, 2/3. Well, okay, here's y equals 0, here's y equals 1, here's about 2/3 of the way, so that's the y-intercept. And then we draw a line through those 2 points. Okay? And that worked out just fine. Now we do for the second equation. Well, if we plug in y equals 0 to get the x-intercept, we get 5x equals 19. Now, if you don't see that, you might want to write it out. But then x is going to be 19/5. So we find that the intercept, well, the x-intercept is 19/5, 0. Now, where is that? Well, how big is 19/5? Well, 5 goes into 24 times, so this is almost 4. And where do we run into a problem? Well, here's 0 and here's 1. 4 is out here somewhere in the air. Okay, it's off the board. So I had to draw a bigger picture. So I redrew the picture. I put my line for the 4x minus 3y graph here. Here's my -1/2, 0. Here's my 0, 2/3. So that I could come over here and plot the point 19/5, 0. Now, to plot that point, and this is kind of worth thinking about, 19/5 is 3 4/5. And certainly we know how to get that. Just, 5 goes into 15 3 times, 4 left over, so it's 3 4/5. And to get 3 4/5, well, that's between 3 and 4. So I can divide the interval between 3 and 4 into 5 equal parts, and I go over 4 of them. There's 3 and 1/5, 3 and 2/5, 3 and 3/5, 3 and 4/5, right? And 3 and 5/5, but that's 4. Okay, so there's 3 and 4/5, and that's kind of how I construct it. If I want to make a reasonably accurate hand-drawn graph, I should do something like that. And then what about the y-intercept? The y-intercept. When x is 0, you're going to get 7y equals 19, so y is going to be 19/7. 19/7 is not quite as big as 19/5. This is almost 3, whereas this was almost 4. Okay, well, 19/7 is actually 2 5/7, so we come up 1, 2, and then we break the interval from 2 to 3 into 7 pieces, and we go up 5 of them. Okay, well, there's our points anyway. So now we draw a straight line. Now the board's wobbly, and my angle wasn't real good, so I didn't get real good straight lines, so I don't expect that we're going to get a great approximation. We had a pretty close approximation on my graph here, okay? I didn't have a whole lot of confidence in this, and my lack of confidence was totally justified. Okay, well, these points cross here. If I project this point down here, it looks like I'm at about 1.3, maybe even approaching 1.4. So the x-coordinate, I think, is 1.3, according to the way I drew the graph. Okay, the y-coordinate, well, the y-coordinate came out pretty close to 2. Okay, and actually I projected over from a point a little bit too low. If I do an honest projection here, it's probably more like 2.1. But I'll leave the 2 there. Okay, so I get 1.32. Now what should the point of intersection have been? Should have been 1, 2. Okay? So I got a little bit over too far this way, and actually the point is a little bit too high. And that's partly because you can see there's a little curvature to the graph. A straight line between here and here would have hit closer to here, but it still wouldn't have gotten 1. It probably would have gotten 2 pretty well. Okay, so one thing you see is a hand sketch is not a very reliable way to get an accurate result. The way you get an accurate result is by doing the algebra. Nevertheless, the hand sketch tells you if your answer makes sense, okay? And 1, 2 certainly makes sense if a hand sketch says it should be 1.32.